Hi, everyone. Thank you for joining me today. I'm El-Khoury of the Yale School of Medicine, and it is my pleasure to welcome Dr. Mark Zaydman, who's an assistant professor of pathology and immunology at Washington University in St. Louis, and also a member of the pathology informatics. Mark, welcome, and thank you for joining me today.
Thank you, Joe. It's a pleasure to be here.
Absolutely. And I'm really excited today to be talking about a topic that's been on mind, large language models. And I know there's obviously ChatGPT has been a big change in the recent year, kind of seeing how that's been impacting every industry. So we're here to talk about large language models and its applications in laboratory medicine. So the first question on top of anybody's mind, and especially me when I first got into this, is what is different between large language models and machine learning?
Great question, Joe. So first of all, as the name might suggest, these models are very large. So you're talking about machine learning and AI tools that have tens of billions of parameters. But it's not just the scale. These are models that are processing language, hence the language part of large language model. And what you're going to use them for might be different than conventional machine learning. So let's take a step back. So I think when you say conventional machine learning, you're usually talking about a supervised classifier, which is going to take some input, for example, features from a patient's chart, and provide a classification as an output. This patient has sepsis, this patient has AKI, or does not. These models now are more geared towards language. So the input is going to be text or human language. And then the output can vary. There are classification language models. There are models that take text and convert it into a vector of numbers. But the most famous ones that we have, like ChatGPT, are generative models, which means they're going to generate new text or an image in response to that text input. And what has been really remarkable in the recent years is that as these models get larger and larger and larger, they start to do these really wondrous things. They can summarize text. They can write a poem in the style of your favorite poet, so on and so forth. And interestingly, there seems to emerge some intelligence where you can ask it a question on different topics, and it will provide a response that can be pretty convincing, though not always accurate. And I'm sure we'll talk about that going forward. So the analogy I give is, the conventional AI will take your email and say, this is spam, this is not spam. The new generative large language model empowered AI will actually write an email to you.
Wow. And I also have seen kind of going through the literature discussions on small language models. So perhaps before we dive deep into large language models, can you clarify the distinction between those large language models and what we call small language models?
Yeah, it's a little bit in the eye of the beholder, but there are certainly models that are smaller in terms of the number of parameters that they have. And that has a lot of practical implications. So it's very hard to train and run a very large language model. So typically when we're utilizing those large language models, like ChatGPT, we're using some sort of service where we might submit a query, for example, in a web page, and then get a response back, but that model is actually running at some remote site. These small language models might be more compact to where you could actually run that locally without having to have a ton of computing resources. And that could be really useful for several reasons. One is if you work with patient data, as I think you do, Joe, and I do too, you don't want to be sending patient data through some web service. The other is that you might want to train that model to be really good at your specific task, right? And so you might use more of a conventional supervised machine learning approach to provide the model with additional examples to learn from. And it's a lot less expensive to train a smaller model than it is those massive scale models. So I think most institutions are going to be using small language models if they're going to be doing additional fine-tuning and training, or they'll use a large language model with some alternative training paradigms.
And taking a dive into some of the applications that you've hinted to, so looking at large language models specifically, then what are some applications that are exciting that you see in lab medicine?
I think lab medicine is fundamentally about communicating useful information to clinicians to inform clinical decisions. And when we communicate, we use language. And so there's so many tasks in our workflow that require us to take language, to process it, to present it in a different way, what we call a transformation of language. And often those tasks are very manual and very expensive. And so I think there are a lot of opportunities to use these large language models to make all those processes much more efficient. And I think that to me is the most exciting application right now. So let's give you some concrete examples. So one would be, I am a pathologist that signs out SPEPs, serum protein electrophoresis. And patients, so I'm looking for a monoclonal immunoglobulin when I'm signing out that study. And a lot of our patients are on monoclonal immunoglobulins as a therapy for their disease. And so, of course, that can be very confusing. Are we looking at an artifact of the therapy? Or are we looking at data, some feature that might indicate disease? So how do I figure out if the patient's on daratumumab, the therapeutic monoclonal antibody? Well, usually I have to go to the patient chart and sift through note after note after note in order to figure out, is this patient currently on this therapy? So imagine if we could just have an AI tool do that for me and would just float those relevant passages and say, yes, patients on DARA, look at this section. That would make my life so much faster. So much easier, and my sign out so much faster. So similarly, in the blood bank, daratumumab can interfere with blood bank testing. That's an example of how you could use a large language model for what's called information retrieval. We have a lot of unstructured text, and we want to mine specific information in order to inform whatever process we're doing, in this case, signing out SPEPs. We are working on another application, which is we're trying to use large language models to generate explanations of laboratory testing for patients, and to do so in 6th grade English. And I think this is a really exciting application. The history here is we had a presenter come and talk about health equity, and a great resident question was, what can lab medicine do to improve health equity? And without missing a beat, this presenter said, you need to change all your reports into plain English because no one can understand pathology reports. And I think that's probably right. And so I thought, great, I'm in charge of SPEPs. I'm going to go write a 6th grade English, and 6th grade English because that's the recommended reading level for patient-facing material. So I sat down and I was all ready to do it. And I thought, oh, I have no idea how to speak in 6th grade English. And so then I went to ChatGPT and I said, explain serum protein electrophoresis to a 6th grader. And the response was remarkably consumable, although pretty inaccurate, right? So we're trying to now adopt these newer approaches to improving the accuracy of large language models to leverage its ability to take a sophisticated concept and generate information in written form in that more readable English, but also to maintain accuracy suitable to clinical use.
That sounds awesome. And I'm curious, for anyone who has other applications of lab medicine, how do you go about building such algorithms and tools to use in such a way?
Yes, that's a great question. There are many different approaches that can be used. Obviously, there are web services that give you access, such as ChatGPT, to these very powerful models. Now, again, be careful. We should not be putting protected health information into ChatGPT, since that's not a HIPAA-compliant system to work with. So your question, though, was how do you work with these models? You have different options, right? Ideally, you'd have a model that's locally hosted in a HIPAA-compliant framework, where you can make sure that model's not changing over time in ways that you're unaware of. Some institutions are probably providing access to these models because they're pretty expensive to host. And then you have to decide, how am I going to put these models together into a pipeline to solve my problem? And again, there's a lot of engineering and there are a lot of options, okay? And these range from, I'm going to train a model from scratch, very expensive. So for example, GPT is tens of millions of dollars to train initially. I could do a lighter weight training called fine tuning, where I take this pre-trained model and I'm going to provide it a couple extra examples to make it do better at my problem. Still pretty expensive. And then finally, there's this whole framework called in-context learning. And in context learning, you're not actually training the model. You're not changing its parameter weights in those hundreds of millions of parameters. Instead, what you're doing is when you submit your query, you say, I want to know about liver function testing. And here's this textbook on clinical pathology. Use the information in this textbook to find the answer. And so that's called in context because you're providing as context this additional domain knowledge, right? And so this is kind of the cheaper way to get around having to retrain, but it's also a very powerful paradigm. So now you've converted this task into an open book test where the large language model has the reliable information and it doesn't have to hallucinate an answer from its training corpus, right? And so there are different paradigms like retrieval augmented generation that can be used for that. I think probably retrieval augmented generation, or RAG, is going to be the most useful for laboratories. And you can imagine the context you could provide could be textbooks, could be all your protocols for laboratory testing, could be EHR data so that the model has access to the specific patient's clinical data when it's making a response to your query.
So, I mean, those all sound like very complicated concepts, Mark, right? What can laboratory professionals like myself who has no basis in this, how can they learn and where can they go to basically develop the skills needed to learn how to build some of these applications?
Yeah. So first of all, we don't have to work alone. So I think laboratories should develop collaborations with computer scientists, with data scientists, with clinicians, right? Where we can leverage our laboratory expertise and bring it to the table. So the first thing I would say is we should, start building those teams to focus on solving laboratory questions. If you really want to pull up your sleeves and get into it, there are great resources out there. The computer science and data science community has quite a presence online with outstanding educational material. And a lot of residents feel like they shouldn't go to YouTube, but you should go to YouTube.
Absolutely. If anything, this is an example of that.
Exactly. You don't know what you'll learn on YouTube, right? There are great tutorials with source code, summaries of important papers. The field moves so quickly that these types of channels are really important educational resources. There are also different communities like Kaggle, where you can learn through competitions around machine learning and whatnot. Now, in terms of literally how do you do it, you're probably going to need some programming skills, but there are a lot of open source, meaning code and models that are available for free for you to pull down and tinker with. You can even change them if you so please. So the barrier has never been lower to getting started. There's really democratized access to these types of tools. So I would say what I always say, which is find a problem you really care about and just go get started and be willing to suffer through some pain along the way.
Absolutely. And I think it's also worth mentioning, I know you've been very active with the Association for Diagnostics and Laboratory Medicine in hosting a competition every year at the annual meeting. Can you speak about that and how that can help with people trying to get on board with some of the educational needs to basically develop some of these tools?
Oh, absolutely. We've run a data analytics challenge for 3 years now. And this was really modeled after this community of online competitions in the machine learning field. And what they do is they take a real world problem, they post a real world data set, and then they have a prize for whoever solves that problem the best. And the idea is really to build community and education around applications of these tools, as well as to solve some outstanding problems. So I thought that would be a fantastic way to engage the membership of ADLM around data analytics and to start to build those resources and skills. And so first 2 years, we were working within the Kaggle framework, and we had great participation. The prize was that the winner got support to go present at ADLM with meeting registration. And then we all got to learn how they built their winning solution and ask them questions. So this year, we have a very unique challenge. We've shifted from kind of a Kaggle type competition into more of a let's build and fill a missing gap in the analytics space as a community. And so the challenge this year is to build tools that help to monitor for fairness in laboratory testing. And because we're outside the Kaggle framework, we were able to come up with a really clever scoring rubric. And so folks are getting scored based on the functionality of their tool, the quality of the visualizations, adherence to all these best practices in data analytics. And then they get extra points if they engage their local experts and find an end user and plug in their own data and learn about fairness in their own laboratory testing. We really wanted to galvanize people to act and to start moving towards monitoring fairness, and then also to start building those relationships with experts in other fields at their institutions. And so, as always, the winner is going to get to present at ADLM in July in Chicago. And that presentation will be at the Health Equity and Access meeting. We're co-hosting this year's competition between the Data Analytics Steering Committee, the Health Equity and Access Division, as well as the Informatics Division of ADLM. So we're very excited. There's still time to compete for all those listeners out there. So please look up Fair Labs ADLM, and you can read about the competition and how to participate.
Absolutely. And I'll just add the deadline for those of you interested is May 15th. So please, you still have time from the moment this is posted, and the presentation will be in July this year, or the competition will be in July this year. But it's great to hear you speak about algorithm fairness, because obviously this is a topic that's come up recently because of all the things we've learned, with EGFR being one example where we've recognized we've been unfairly, for the wrong reasons, not necessarily being intentionally biased.
Sure.
But it's not like in most cases, these are unintentional decisions that are made based on incomplete facts or inaccurate facts that lead us to basically practice medicine with a bias. And hopefully with a lot of these developments, we're able to fix and correct these biases so that the future generations don't have to obviously deal with the mistakes of the past. So I'm curious, kind of competition aside, what other projects, because I've known that you've also had some examples with the competition focused on hemolysis. Are there any other applications that are like pre-analytical focused that would be of interest in terms of improving quality and help, and where large language models can play a big role as well, that you can share?
Yeah, a great question. And it occurs to me that next year's competition will have to be using large language models. It's decided from this conversation, Joe.
I'm glad to have had an impact.
Yes. Yeah, I mean, absolutely. I think we can basically devise a couple buckets of applications. So one is going to be retrieving information that is necessary to make decisions in our workflow. Another is summarizing those information and then communicating them to the next step in our process. So in pre-analytics, obviously most errors are occurring during the pre-analytical step, and often pre-analytical errors are occurring outside of the laboratory. So it can be very difficult for us to track and to control. Honestly, I don't know if I have yet a good application of large language models in pre-analytics. We're doing a lot of work to provide feedback and education to our specimen collectors on hemolysis and blood culture contamination. But there we've largely been using more classical statistics, trying to identify folks who are underperforming relative to their counterparts and to provide that information back. You could imagine right now our educational intervention is static. We've created a little training module emphasizing 5 important tips for how you prevent hemolysis, for example. But that's a one-way flow of information. So now imagine if instead of that static module, you could have a chatbot tool where the end user could ask in response in dialogue with the information you're presenting, right? To say, I don't quite understand that point, right? Why wouldn't I use an IV catheter draw? The patients don't like to get stuck. What should I tell the patient when they ask me, why are you performing another venipuncture when I already have a catheter? And then you could have a tool that could be dynamic, right? And much more interactive. So that might be a way you could leverage large language models in that pre-analytical space to provide a next level, next generation educational intervention tool.
Awesome. And as a laboratorian thinking about all of these applications, what always comes to mind is where will this be housed, right? Because we think in lab medicine, is this going to be on my instruments? Is it going to be in middleware? Is it going to be on the laboratory information system or hospital information system? So where would all of these applications go, whether it's large language models or machine learning models in terms of the infrastructure that we have currently in the lab?
Mm-hmm. So I don't think you're going to integrate these models into middleware, LAS, instrument. Instead, I think they'll be hosted as a service on a separate server. And then you'll have some sort of application programming interface where your LAS can communicate back and forth with your analytical application. That's challenging to do right now. So a lot of laboratories do not have read-write access at their different steps, the instrument, the middleware, the LIS, and so on and so forth. So I think one thing we can all do is we can start to build those access points and try to engage our vendors to help us develop those access points. But ultimately, these models are going to be hosted and kind of a third-party service towards that data stream. But we need to be able to make decisions at the point of testing, right? So we don't want these to be tools that once a result is reported will retroactively identify, a change or an issue that should have been raised while that sample was still on the instrument. So I think the implementation science part of this, how we take a tool not just through proof of concept, but into clinical use, will require a lot of research and a lot of attention. And I think that's where lab medicine can really lead in how we translate these tools effectively to improve laboratory testing.
Thank you. And finally, any advice you would give to laboratory professionals who are interested in this and staying on top of it, especially since many of these applications, again, start outside of lab medicine and then all of a sudden end up being a lab medicine problem. So any advice you can share with laboratory professionals about how to approach this issue?
Yeah, I think one is don't be afraid. It's fun to go and play with these models and explore. So if you're feeling courageous, I would suggest, again, as I do to all trainees who are interested in data analytics, find that problem you care about and go, get the tools and start to work on it. I think a second is, we all need to be a bit skeptical. There's a lot of hype around these tools, and we need to apply the same rigor we do to any other new technology. We need to see the clinical validation data. We need to have procedures and processes for monitoring quality and performance post-deployment. So I think the fundamentals of lab medicine don't change as we bring these new models on board, and we should keep that in mind. 3, for all those pathologists who think their jobs are going away, I'd say, rest easy. We're not going to be replaced by AI in the future. I think how we do our jobs might change, and hopefully for the better. Hopefully those very laborious and, not rewarding tasks are going to be more automated, and we'll be able to do our jobs faster and better using these tools. So if we're going to participate, we're going to lead, it doesn't matter if you can't code the pipeline for the large language model application yourself. Your testing process, the problems and the pain points. And so your expertise and input is invaluable as we start to design these tools. So I guess the place I'd like to leave it is don't be a bystander, be part of the team when it comes to developing applications of large language models.
That is valuable advice. Dr. Mark Zaydman, thank you for all your insights today, and thank you all for watching.